Hi, my name is Tiyash and I'm going to give a brief synopsis of my research project. Our lab works with nitric oxide, and this is a very important biomolecule. It has several important roles in the human body. Therefore, it is very important to have an optimum concentration of this molecule released from cells, and any deviation, either high or low, can cause diseases. One such disease is cystic fibrosis. This is a disease that affects mainly the Caucasian population and is characterized by inflammation of the lung airways and other organs of the body. The levels of nitric oxide has been found to be low in cystic fibrosis, and the unique aspect of our project is that we are trying to, for the first time, detect nitric oxide at the level of a disease cell line model. The challenges in detecting nitric oxide in cell lines is the fact that nitric oxide is a very volatile molecule, and as soon as it is produced, it diffuses out of the cell rapidly and reacts with other biomolecules and gets converted to byproducts. Also, the concentration of nitric oxide release is low, especially in disease cell line models. Therefore, we need a very sensitive and selective analytical tool to detect nitric oxide in real time and accurately. This is where our electrochemical sensors come into play. We fabricate these carbon fiber based microsensors, and we modify the tip surface with a polymer and a transition metal catalyst. And with this composite structure, we get very high sensitivity and selectivity towards nitric oxide, as well as a very fast response time, as well as a very low limit of detection. And because of the miniaturized size of this sensor tip, which is actually thinner than a single strand of human hair, we can accurately position the sensor above a cell line and stimulate the cells to release nitric oxide. So when we stimulate the cells to release nitric oxide, we can capture the nitric oxide very quickly because of our very fast response time of the sensors, which is usually in the level of a few milliseconds. And we can actually prevent it from forming any other unwanted byproducts. In this way, the end goal of our project is to develop a sensing platform for using nitric oxide as a biomarker for identifying diseases where the release of NO is decreased. So that's what sums up my project. Thank you for listening.